Hi everyone, in this video I'm going to explain to you about 9.2, the photoelectric effect. So I have here a metal with a very specific work function. W naught is a work function. Now the equation for the work function is equals to W naught equals to HF naught. H is the Planck's constant, where the F naught is the threshold frequency for this particular metal. So let's start with the what is happening in photoelectric effect. So we start with by shining a light or a photon onto this particular metal, on the surface of the metal. So as the photon strikes on the metal, what happens? It carries an energy, and I put it in this orange marker. E equals to HF. E as in energy, H is in Planck's constant, F is a frequency that carried by these particular photons. As it strikes, as the light hit the surface of the metal, it gives out energy to the free electron. And with this enough kinetic energy, or we consider it as K max, this electron will be ejected out of this metal. And these electrons is called photoelectrons. So what is the equation that showing this whole process? So we start with Einstein photoelectric equation. So what is that? K max, which comes from the free electron or the ejected electrons, equals to HF given by the photon minus the work function of this particular metal. Okay, so dekat sini saya ada bagi satu metal. I have this one particular metal with a work function 2.0 electron volt. Saya bahagikan kepada 3 bahagian untuk menunjukkan 3 case yang kita akan tengok satu persatu. Let's go straight away. Now the first case, I give a photon which is HF equals to 2.25 electron volt with a work function 2.0 electron volt. We can see that the photon is actually having excess energy, and what happened is electron will be emitted out, will be ejected out with K max equals to 0.25, since we know that K max equals to HF minus work function. So we can see that it is just a simple mathematics. We can see that the K max equals to 0.25 electron. So what happened? In this case, case 1, HF is bigger than the work function. What happened? Photoelectrons ejected from metal surface with excess energy K max. Now let's take a look at case 2. I have this one photon with the HF equals to, the energy equals to 1.77 electron volt, whereas the work function is 2.0 electron volt. What happened then? So we can see that in case 2, HF or the energy of this photon is much less than the threshold frequency of this particular metal. So what happened? There is no photoelectron is emitted. So there is no photoelectric occur. Let's take a look at case 3. I have again another photon with the energy carried 2.0 electron volt. Look, since we have the work function here the same with the energy carried by this photon, what happened is all the electrons can get out of the surface, but the K max is 0. So in case 3, we can say that photoelectrons have emitted on the metal surface but has no kinetic energy to move out. Alright? One more thing that we have to remember, the intensity of light does not affect the emission of photoelectrons. So it means that whether we have low frequency, even we have low frequency like this, or low energy like this, but we shine it like in a spotlight, very bright spotlight, it still will not give out the electron from the surface of the metal. But for example, we have this frequency. Although it is dim as possible, we can still see photoelectrons emitted from the surface. Maksudnya, terang macam mana pun, kalau frekuensi tak cukup untuk melawan threshold frekuensi pada metal ini, kita masih tak akan dapat photoelectrons yang keluar daripada permukaan metal. So I hope it helps. Alright, bye-bye.